Okay, so in part two, we're going to talk that you can have some of these curves memorized if you want. These types, when you're in this general form here or here, you could have this little loopy, or it could be a dimple. Circles are going to be in these general forms, or just r equals some constant is also a circle. It's going to be centered at the pole, okay? And then there's going to be lots of pretty ones. It looks like infinity signs whenever you have an r squared. When you have the cosine and sine of now even or odd numbers, you're going to have these rose curves, these beautiful flowers. When it's odd, the number of petals is the inside, and when this inside's even, you're going to double the petals. And so you can have those memorized, or you can just sketch these with using an r theta chart and some of those things. And I like to do that to really understand what's going on in the graph, and using the tangents at the pole. Okay, so here I'm going to always start by finding the tangent at the pole when I want to go graph. So I'm going to say, where does this equal 0? Oops, I do not know why I just wrote sine, cosine. So this is where cosine would equal -1 divided by 2, -1/2. This is where we have to know our unit circle really well if you want to go practice. So that's at, what, 2 pi over 3 and 4 pi over 3. And then we just kind of check that it's not the first derivative. These are not zeros, and we're good. Now, even if they are, sketching these lines still help me when I am graphing. They kind of just guide. So I always like to sketch them even when they're not tangents at the pole. All right, so the first one was at this pi over 3. And the second one was at 4 pi over 3. Okay. All right, so now I'm going to make my r theta chart and just kind of go in order. So we're going to start at 0 and plug in. So that's 1 times 2 is 2 plus 1 is 3. So I know that when I am facing 0, I go out to 3. So you can do pi over 4 if you want, or pi over 6, but I'm going to go ahead and jump to pi over 2 and get the basics, and then if I feel like I need more, I'll go back and get them. So here, plug in your pi over 2, see what you get out. Hopefully you said 1. So now I'm facing pi over 2 and I go to 1. And then I always want to include these guys in my chart for the flow. And I know that before pi, 2 pi over 3 is going to come. And we've already found that that is a 0. So that's kind of important because now I know that I'm not going anywhere when I'm here at this 2 pi over 3. So now I'm going to go ahead and do pi. That's going to be -1 times 2 is -2 plus 1 is -1. Okay, so facing the pi direction, we go back to -1. So as I kind of see what's going on, I am moving in this direction, hit here. Now I'm going to have to loop to get to the pi. Let's keep going. So then after the pi, here's this 2 pi over 3. Gives me a 0. Or not 2 pi over 3, 4 pi over 3. So now I'm back at 0. And now I'm going to plug in my 3 pi over 2. That gives me 1. And are you seeing the symmetry here? Then we can go to end it. And if I plug in the 2 pi, I am back to 3. Okay, so that's one loop, and hopefully yours looks a little bit prettier than mine. But here is the graph of that polar equation. Try not to be so Humpty Hump right here. Try to make that, yeah. Okay, make sure you're showing me the direction that you are moving. That's going to be important. All right, let's try to graph the next one. So let's see if we have any zeros, any tangents at the pole. So where does cosine of theta equal -3 divided by -2 would be 3/2 I dk on this one. So I really don't know any tangents I'm going to graph here. So we're going to go to our r theta chart because I can't solve that. Like the arc sine of 3/2, you could do that. Amazing. Okay, so we're really going to just put some in here and flow in order. So we're plugging them into my r, or to the theta, and solving for r. So that's 1. Go to pi/2, and again, if I need to have more, I will. That goes to 0. Pi, that's -1, -2, 5. Pi/2, back at 3. And then looks like we're ending at 2 pi, that we are back at 1. So let's go get those. I'm going to move me. Okay, so here I'm going to go, as I'm facing 0, I go to 1. As I face pi/2, I go to 3. As I face pi, I go to 5. 3 pi/2, I go to 3. And then we're back where we are. So here there's nothing so hard to do a pretty line. Okay, looks something like that. Okay, so see how there's nothing going through the pole to really have a 0 ever, so that's why there's no tangents at the pole. Okay, let's graph the next one. Maybe. I don't know why that just stopped working. All right, so here we are. Let's find where this guy equals 0. Oh, because I had it on eraser. Why do I do that? So where does sine theta equal -2, -2, 1? Pi/2. And that's the exact same line there, so I don't want to write it twice. And then when I find my derivative, that was my r, I would have -2 cosine theta. That's not 0 there. So we're fine. Okay, so I'm going to do my tangent at the pole. Now I'm going to make my r theta chart. So plug in your 0 and just keep moving along. See if you get the same as me. Try it on your own, make sure that you're good. Remember, it's kind of this curvature motion. You can't just ever draw straight lines. A little too thin. Usually these are fatty. Make sure you draw some fatty curves, big hearts. And that's what I got. See how that looks for you. And I know I should have been putting in where these start and stop. It will really help us in the future if we know where these theta values were. Okay. Okay, next one, r equals 3. Well, can never equal 0, so, and no matter what I plug in here, I get out 3 the whole time. I get out 3 no matter what. So this is just a circle centered at the pole. Pretend that that's a circle. Okay, next one. Okay, so let's find where this guy is 0. 2, and then they repeat. And r prime, -2 sine theta, not 0. Okay, so we've got this tangent at the pole. And then let's make our r theta chart. Plug in 0, 1 times 2 is 2. Pi over 2, we already know we're at 0. What about at pi? We're at -2. Oh my goodness, look at this. So we've got from here to here, and then we went here to here. We have already completed a full rotation because when I facing pi, I go back 2. So this happens again at pi. This was at 3 pi over 2, and there's my circle, and it's already completed a full rotation by pi. Not 2 pi. Usually it takes all the way to 2 pi to get a full rotation. Okay, one more page of graphs. Let's make a graph this now in quadrants 1 and 2 only. So let's go see. This is theta times 1 plus sine of 2 theta equaling 0. So theta would equal 0, or 1 plus 2, or sine of 2 theta equaling 0. So where does sine of 2 theta equal -1? Remember, sine equals -1 down here at 3 pi. So where does this equal here? And that's at 3 pi over 4 is going to be my 0 here. All right, so when I do my r theta, I know I'm going to include that. And if I'm having to get a 4 in there, I'm probably going to have to go to pi over 4 next before pi over 2 is my guess. Okay, so I know 3 pi over 4 is right here. Okay. And I'll go pi, and let's see how we do. Okay, so plug in your 0. We know that we are 0. And then plug in pi over 4. So pi over 4, I have pi over 4 times sine of pi over 2, is 1, 1 is 2. So I get out pi over 2. Is that right? Okay. What about at pi over 2? Pi over 2, this is pi, oh, plus the 1. Shoot, hold on. Let me go back to this one really quick. Let me get some more room. So I'm going to plug in pi over 4. So that would be pi over 4 times 1 plus, no, I think I did that right. Pi over 4 would be pi over 2, so sine of pi over 2. So that is 1, so that is 2, which would give me pi over 2. Okay, that was good. So let's go ahead, oops. Let's do pi over 2. So that's pi over 2 times 1 plus sine of pi over 2. Pi over 2 would just be pi now, which is 0, and I get out pi over 2. At 3 pi over 4, we already found out that we are a 0. And now let's go plug in pi. So that would be pi times 1 plus sine of 2 pi is 0, which gives me pi. Let's see how we do on that. Okay, when I face pi over 4 right here, I go out pi over 2, so 3.14 over 2 is in between 1 and 2. So I know that I am in between, there's 1 and 2, so we'll just kind of go in between there. Remember, we have to move circularly. And now I am facing pi over 2, and again I go in between 1 and 2. And then I am at 3 pi, which is going to get me to 0. And then it looks like I go to pi, I'm at pi, so it's a little over 3. And it kind of does this thing, and that's where that tangent at the pole is helping me. Okay. Okay. Let's go do our next one. I don't know why, that one looked weird. Hold on. I want to check. I feel like I'm not doing this right. Let me check that one more time. I just feel silly. Okay, so pi over 4 times 1 plus 2 sine of 2 times pi over 4. That's where I messed up. No, that's right. There's no 2 times sine, it's just, okay. Sorry. Talk amongst yourselves. Yeah, that's 2. And then 2 times that's, yeah, that just looks really weird. Okay, let's go on to the next one. So I want to see where this guy equals 0. Basically, where does 4 theta equal 0 and pi and 2 pi and 3 pi and 4 pi and etc. And then I divide by 4. And then I start to repeat because 0 and pi are the same. So I've got 4 tangents at the pole. Is anybody thinking, oh, pedal? Okay, so you're right. Let's go ahead and get those in. I have 0, pi over 4, pi over 2, the 3 pi over 4. Ah, that one was horrible. Okay, and I know that this is even, so I'm going to have 8 petals because we double the even. So let's go see what we can find in an R theta chart to help us out. So we already know what happens when I use those. So at 0 and then at pi over 4, I know that these are 0. So let's pick something in the middle of those two, and let's see what happens. So let's try like pi over 6. And I'm going to let you go ahead and use your calculator, and I want you to see what you get here at pi over 6. So sine of 4 times pi divided by 6. And then we want to multiply that by 4. Okay, so got about 3.5. So this is telling me that when I am at 0, I'm at 0, and then at pi over 6, I am at this like 3.5. So this one go by ones. 1, 2, 3.5, about right here. Okay. So when I kind of am making them, I know that my petals going out somewhere. Oh golly, that was hard to do with this guy, but you can use your graphing calculator for now to see that as well. But you know that the petals are going out that length, okay? Kind of on the ending of it, a little bit more than that then, since it had to go. And pretend that they're look pretty symmetrical, okay? Okay. So the other thing you could kind of see is that this is the length of the petal. So I know that like the very top is going to go to 4. I really should have made those bigger. Let's just try that one more time. Let's go in orange. So let's go out 2. Then there's 4. So 4 is at the very edge. So right in the middle of those two guys, I know that I should have been going out 4. That looks so much better. So there's my 4. There's my 4. Right in the middle. Oh yeah, this is looking way better. Well, it was. So ignore the purple. Look at the blue. Or look at the orange. Oh, that was bad. That looks like a much better. Oh, I didn't know that. Okay, we'll kind of pick up. Now they do not go like that, how I'm doing now. They are more flowy as they move, okay? But that looks a little bit better. Okay, last one. Ooh, I see an R squared. I know I'm going to get an infinity of some sort. So let's set this equal to 0. So cosine of 0 at pi over 2, 3 pi over 2. Keep going. Let's see if we need that. So that's pi over 4, 3 pi over 4, so pi over 4, 3 pi over 4, and then we'd be at 5 pi over 4, which is already the same thing. Okay, so that's good. So now I'm going to make this r theta. Now when I plug in, I can get 2 different values. So if I see this, I can see that r squared, when I plug in 0, cosine of 2 times 0, 0 is 1, is 9. So I can get plus or minus 3. So when I'm at 0, I go out 3 in actually both directions. So I know I'm at 0, pi over 4. And then, you know, like, it's up to you kind of to graph the symmetry and everything. I see enough here that I could finish and, like, knowing what I need to get my graph. Okay. All right. Now that we have a basic, we're going to move on into the fun stuff next time.